Okay, so as promised, we are finishing our video lecture notes today. You've already watched one video. I hope you took a little bit of a break, maybe a 5-minute break before you started these, just so your mind is nice and fresh. We are going to this page in your notebook right here, please. Once you've found that page, we'll get rocking and rolling. So we talked in the other video about the really scientific words about groundwater that I thought you needed to know and about the water cycle in general. Kind of outlining the different parts that when we really do start to dig deep into groundwater and surface water interactions like we're doing right now, then you're really going to understand what we're talking about. So I hope that those words, maybe if you think vocab isn't your thing, maybe this would be an opportunity for you to create some vocab note cards so that you can practice using these scientific words as we continue through our hydrosphere lecture. So moving right along, so we were talking about the interactions between groundwater, that water that is underneath the ground, and surface water, the water that you can see that is on top of the ground, whether that be lakes, rivers, puddles, whatever, the ocean. They interact somehow. So I want to talk about how we get the groundwater out of the ground so that we can use it, because we do. It's what we use typically to drink, unless you're in Wilmington, then you use water from the Cape Fear. Might use a little water from the Cape Fear here, but most people would be drinking or using water that's from a well. Here we go. We have a couple different types of wells. We have an ordinary well, which is a hole that is dug below the water table and fills with groundwater. With our ordinary well, pumping is necessary. Several wells drilled into a given area will deplete the groundwater. So think of this if you're sharing a milkshake with your friend, which we wouldn't do with COVID anyways, but say you had one milkshake and you had you and 2 other friends. If you are all 3 drinking the milkshake through a straw at the same time, that milkshake is not going to last very long. Same thing happens when we put more than one well down into the same groundwater supply. Eventually that water will be either used up or go far below the water table, so we won't be able to use it anymore. So that's an ordinary well. We have a different type of well we call artesian well. So this is kind of special. The groundwater rises on its own due to the pressure of the well. So typically this would be drilled into a low-lying area where the water table is well above it, so that regular pressure from just the water table decreasing is going to push the water out. Like I said, the pressure is due to the water being sandwiched between 2 impermeable rock layers as well. And no pumping is necessary. So for this one, it's passive. You do not need energy. With our ordinary well, we do need a pump to be able to bring that water from underneath the ground to our house. In this, we do not. The pressure is already there with just the way that the aquifer lies between 2 impermeable, so probably clay, layers where the water is not going to go below and it's not going to go above. So there's already a pressure system created, and that will cause the water to, on its own, go out, and you will have your own well that has no pump to it. A couple things that we need to talk about with using our water supply. So if you can imagine, if you've got a layer of rocks and there's water in between the layer of rocks, that water is going to take up empty space. While it's not solid like ice or anything, it is going to kind of take up empty space in between those soil particles and make them more sturdy. What happens when we pump the water out of the ground too much, we get this geological phenomenon called subsidence. There you go, subsidence. And it's the sinking of the Earth's surface in response to the geological or man-made induced causes. So this would be like a sinkhole, right? So sometimes this can happen just because, you know, there was some kind of geological event, maybe an earthquake, and it caused it to happen. Other times we take the water, if we take the water out in between the soil molecules have a chance to rearrange themselves, maybe get a little closer, mix a little bit more, eventually causing a sink, right? So you could sink right down into the ground. That's what happened with this house in the picture right here. So if you look at your notes a little bit, you can see that even more. So as we deplete our water right there in your notes, so with the first picture on the left, as you take out more and more and more of that water, or in this case, it looks like soil has gone down and filled a hole in the bottom, that cavern is created. As the cavern is created, eventually you get actually like a cavernous layer. So under my hand would be the bedrock, and then you have more bedrock, but a cavern of air right there. Eventually, there won't be enough left on top there to support what's sitting on top of it, possibly a house, and it's going to sink. This is an issue definitely in North Carolina. It can lead to the destruction of property and habitats. So in this case, we lost part of the road here. It sunk down into the ground and off and was washed away. In this case, we lost part of this land right here. It all sunk down. It's hard to tell now, though. Another phenomenon that we have when we talk about the hydrosphere is springs. So springs are a section of impermeable rock forces. A section of impermeable rock forces groundwater to move laterally and emerge on the surface of the earth. If you are familiar with White Lake, one of the closer lakes right here, it is actually spring-fed, which means that there is a section of water going down, or sorry, not going down, but in between two impermeable rock layers, and that the pressure system that is created actually, instead of having a well there like the artesian well, it has nothing, but it springs up from the ground all on its own. So that pressure system is created and we have a spring. That is why White Lake used to be so white, because it was spring-fed, so it had a constant source of new water. Okay, so springs, a section of impermeable rock, forces the groundwater to move laterally and emerge on the surface. So instead of the groundwater moving like this, it goes whoop and comes out. Right? We have a couple different types of springs. One is a hot spring. So this is caused by the temperatures are increased as you go down into the earth. The water from the hot springs just originated deeper inside the earth or is heated by magma. So possibly the water that you are experiencing when you're in a hot spring is just deeper down in the earth, so it's warmed by the magma, or it is just deeper inside the earth, and you know as you go deeper into the earth, though we could never feel it because we can't dig that far, it gets warmer and warmer. Okay, so hot springs, the temperature is increased by being in the earth or because it came in close contact with magma, like our diagram right here. Hot springs are pretty cool. I would love to go visit one someday. And then we have the geyser, like Old Faithful and Yellowstone National Park. A geyser is a hot spring that periodically erupts. So instead of being kind of a very relaxed kind of gushing of water, or covered into the lake, most springs will actually form lakes. There are occasional very small, I mean, you can find them anywhere. I hiked once and found one, but a spring that's just bubbling up water very peacefully, relaxedly, but sometimes, especially with the heat, they will erupt like a volcano. This is because of a small opening in the crust. The pressure builds until an eruption occurs, just like Old Faithful in Yellowstone. So it's actually a geological phenomenon that we are getting that national park right there, or national landmark in the national park. And lastly, and we are going to take an entire unit to study the pollution of water, but here's just a little bit of it. Groundwater is renewable, yet limited. So while water is a renewable resource, and the water will eventually come and rain down and then permeate or percolate through the soil, go through the soil, and become groundwater, we are consuming it at a faster rate than we are able to naturally reproduce it. So we are, like we always do, humans, we are taking the water supply and we are limiting it because we are using too much of it. There are other problems with our groundwater right now in our current situation because we are polluting it. Fertilizers, just like water, is a great carrier of things. If you're sitting on a tube down a river, it'll carry you down the river, but it also carries things like pesticides, herbicides, fertilizers, sewage things, industrial chemicals, arsenic, which is naturally occurring and factories mining it and is used in preserving bodies. So arsenic is actually a poisonous fungus, though for some reason I feel like it is also an element, but I don't think so. I'm pretty sure it's just a fungus. Okay, So we are messing up the ground. Not only are we using groundwater at a rate that is not replenishable very easily, we are using water. We are polluting that very water that we are using too quickly. So next time you think about your fertilizer, and we're going to talk so much about this, about runoff of fertilizer and pesticides and how it is getting into our systems, our natural occurring bodies of water, like our lakes and rivers, and how we can possibly prevent it. But that's just a little bit of a foreshadowing, there's another word for it, but foreshadowing is all that's coming to mind of what is to come in our notes and our learning. If you will, you have some graphs on your notes. So one shows how a septic system works. So we take our septic and it eventually will go out into the ground. Right, so if our septic system is leaking, it will take all of that nasty stuff that has leaked out and contaminate our groundwater, and then it might possibly move towards another body of water to further contaminate more of our water supply, more of our hydrosphere. And then same thing, so this time it is a farm though. A farm is leaking in with all of the pesticides and herbicides and the household waste and the livestock waste and the landfills and the underground storage tanks and the local industry. It is all leaking into our groundwater and possibly contaminating us, so it is just something that you need to keep up as a homeowner to make sure you're not leaking into it, and also something you need to be aware of as proper global citizens and citizens that care about the environment too. Where's your waste going and what is happening that you can't see, right? Maybe one day I will tell you the story of Love Canal, New York. It was a major nuclear accident, pretty much, a nuclear cover-up. Maybe one day I will tell you the story of it and how it has to do with groundwater pollution, sort of. Have a great day, guys.